Hello everyone, am I audible? Am I audible? Please let me know. So, very good morning to all the 10th standard students of ICSE. So, we are starting up with the reading of the chapters from chemistry. We begin with the first chapter, that is periodic properties and variations of properties. It is physical and chemical. So, the first thing is the important points to remember. Several attempts were made to classify elements, to arrange them systematically on the basis of their physical and chemical properties. Okay, so several attempts were made. It was in the first attempt. Now, coming to the next important point, that is Dobrynin's triads. According to this, the elements were placed in a group of three called as triads. The atomic weight of the middle element is the arithmetic mean of the other two. For example, calcium, strontium, barium. The atomic mass being 40, 88, 137. So the average atomic mass of the first and the third will be 40 plus 137 by 2, that is equal to 88.5. The second example being lithium, sodium and potassium. 7, 23 and 39. So 7 plus 39 by 2, that is equal to 23. So the atomic weight of sodium will be 23. This classification was discarded because many elements could not find their positions in the triad. The third one is the Newton's octave law. Like 8 notes of an octave of music, the eighth element starting from 1 is a kind of repetition of the first element. However, this method of classification was discarded since it failed to accommodate heavier elements and there was no space left for the elements which were discovered later. So friends, here I can ask you a MCQ like this. Why did the Newton's law of octave fail? A. Because it could not accommodate heavier elements. B. It had no space left for the elements which were discovered later. C. Both A and B. D. None of these. So such kind of MCQs can be framed on this. Coming to the next, Mendeleev's periodic table. According to Mendeleev, the periodic properties of the elements are the periodic functions of their atomic weights. The arrangement of Mendeleev enabled him to place the elements in vertical columns and horizontal rows, which were called as groups and periods, respectively. So you have to remember even Mendeleev's classification was based on atomic weight and not on atomic number. The elements in the periodic table were arranged in the increasing order of their atomic weight. So again you have to remember the elements in the periodic table earlier were placed in the increasing order of their atomic weight. So I can ask you were arranged in dash. A. Increasing order of their atomic numbers. B. Increasing order of their atomic weights. C. Randomly. D. Decreasing order of the atomic weights. Something like that. Now, sixth point, Mendeleev's periodic table has the following main defects. आप इसे defects कहो या drawbacks कहो, एक ही बात है. A. Position of isotopes. B. Position of hydrogen. C. Position of lanthanides and actinides, that is the rare earth elements. So I can ask you dash among the following are the drawbacks of Mendeleev's periodic table. And I can list out all these points and maybe D as all of these. So you have to remember Mendeleev's periodic table had these main defects. First, position of the isotopes. Second, position of hydrogen. Third, position of lanthanides and actinides, that is the rare earth elements. Now, coming to the next, the shortcomings of the Mendeleev's periodic table was overcome by Henry Moseley, and he put forward the modern periodic table, in which the elements are arranged in the increasing order of their atomic number and not atomic mass. Keep this in mind. Okay, so this even can be asked to you. Okay, it was based on the atomic number and not atomic mass. Very, very important. Coming to the next. Coming to the next, point number 8. The properties of the elements are repeated after the regular time interval, or the properties reoccur after a regular interval. Okay, so I think I skipped out this point. The modern periodic law. The physical and chemical properties of the elements are the periodic functions of their atomic numbers. This is a very, very important line to remember. The physical and chemical properties of elements are the periodic functions of their atomic numbers. Coming to the next, the properties of the elements are repeated after the regular interval, or the properties reoccur after the regular interval. Later on, Bohr worked on the Moseley's periodic table, and Bury in the year 1921 gave the extended form of the periodic table, which is now known as the long form of the periodic table. So friends, I can ask you, who gave the concept of periodic table based on atomic numbers? Second, who gave the long form of the periodic table? Coming to point number 10, periodic table may be defined as the table in which the elements are arranged in the increasing order of their atomic numbers. In the modern periodic table, the vertical lines are called as groups. Remember this, the vertical lines are called as groups. There are 18 vertical columns in the periodic table, another important point to remember. The order for the arrangement of the group is from left to right, that is 1A, 2A, 3B, 4B, 5B, 6B, 7B, 8, which is undivided, 1B, 2B, 3A, 4A, 5A, 6A, 7A, and 0. But according to the latest recommendations of IUPAC, the groups are numbered from 1 to 18. Now, yes, you can have a look at this particular periodic table for you to understand it. I'm keeping it a little longer. Okay, and go ahead. See this, the lanthanides and the actinides as well. Going ahead to the point number 13. The elements of group 1, 2, 13, 14, 15, 16, and 17 are called as normal elements or representative elements. These elements have incomplete outermost shell. So you have to remember the normal elements or representative elements are those which have an incomplete outermost shell. Okay, so I hope you'll remember this. The elements of the group So coming to the next point, that is point number 14, the elements of the group 3, 4, 5, 6, 7, 8, 9, 11, and 12 are known as transition elements. So you need to remember which are the transition elements. I repeat, 3, 4, 5, 6, 7, 8, 9, 11, and 12 are known as transition elements. Coming to the point number 15, the elements of the group 18 or zero group are called as the inert gases or noble gases or rare gases, as they have stable configuration following the octet rule. Point number 16. Group 1 elements are called as the alkali metals. Group 2 elements are called as the alkaline earth metals. Group 17 elements are called as halogens, which are the salt producers. Elements of group 18 are called as inert gases or noble gases. The horizontal rows in the periodic table are called as periods. There are 7 horizontal rows in the periodic table. The number of shells present in an atom determines its period. Elements in period 1 has 1 shell. Elements in period 2 has 2 shells. Elements in period 3 has 3 shells, and so on. For example, hydrogen with the atomic number 1 has just 1 shell, that is K shell, so it belongs to the first period. Element, that is helium with the atomic number 2, has 1 shell, that is K shell, so even this belongs to the first period. Then the element lithium with the atomic number 3 has 2 shells with 2 electrons in K and 1 electron in L, and so it belongs to the second period. Then sodium with the atomic number 11 has 3 shells with 2 electrons in K, 8 in L, and only 1 electron in the M shell, so it belongs to the third period. The element potassium with the atomic number 19 has a configuration of 2881, that is 2 electrons in the K shell, 8 electrons in the L shell, 8 electrons in the M shell, and just 1 electron in the N shell. So it belongs to the fourth period. Now remember, first period is the shortest period containing only 2 elements, that is hydrogen and helium. Second period is a short period containing 8 elements, namely lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Third period is also a short period containing 8 elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Fourth period is a long period containing 18 elements. Fifth period is also a long period with 18 elements. Sixth period is a very long period containing 32 elements. Seventh period is an incomplete period. Hi Mayank Raj, very good morning. How are you? So, all ready for chemistry? Okay. Now, here's you can have a look at this tabular form telling you the period and the number of elements. You'll have to keep this in mind. First period with 2 elements, second period with 8 elements, third period with 8 elements, fourth with 18 elements, fifth with 18 elements, sixth with 32, seventh period which is incomplete. Now in group third B and sixth period, the elements from atomic numbers 57 to 71 are present, which are called as lanthanides. Now here I can ask you, which are lanthanides, to which group do they belong to which period do they belong to, and what are the atomic numbers of the elements which belong to the lanthanide series. So these are the possible questions there. Now in group, hi Arushisha, गुड मॉर्निंग बच्चा, हाउ आर यू? बहुत जल्दी गुड मॉर्निंग हो गई आपकी. In group 3rd B and 7th period, the elements from atomic number 89 to 103 are present, which are called as actinides. Stranger girl, hi dear. अभी तक है ना हमारे चैनल के साथ एक स्मार्ट गर्ल हुआ करती थी, आज एक स्ट्रेंजर गर्ल भी कोई आ गई. हाय डियर. Okay, the elements can be classified as first, representative or normal elements, second, transition elements, third, inert gases or noble gases. Coming to the fourth, The inner transition elements, which includes lanthanides and actinides. So the type of elements are the representative elements or normal elements, and the group to which they belong to is 1, 2, 13, 14, 15, 16, 17. Acha, you're new to the channel, stranger girl. Welcome, dear. Now you're no more a stranger to us. You're a part of our family. Okay, bacha. And I think you're late, but still okay. You have two papers in hands, that is chemistry and bio, for which we can help you out. So if you're new to the channel, please, bacha, subscribe to the channel and hit the bell icon so that you will get to know, because we are scheduling to solve almost 10 papers for chemistry and 10 papers for bio. So as a revision, it will make you stronger. First, we shall be doing up the reading session for all the chapters, because that was what was the demand of few of the viewers. So we shall be first reading out the chapters here, and iske baad we shall be doing up the paper solving session. Okay. If you have any friends with you in ICSE, maybe belonging to your school, your class, or whatever, you please spread the word about this. So while we take up the, especially when we take up the live streaming session for paper solving, it should help everybody. So coming back to this type of elements, first representative elements or normal elements, the group to which they belong to is 1, 2, 13, 14, 15, 16 and 17. Whereas transition elements belong to the group 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. And inert gases belong to the 18th group. Hi Sharon. Acha, okay, you're telling me Sharon asked you to join. Okay, but stranger girl, welcome, dear. So, the properties which reoccur after a regular interval in the periodic table are called as periodic properties, and the phenomena is called as periodicity. The major cause for the periodicity is the reoccurrence of similar electronic configuration. In the particular group, the valency electrons remains the same, and thus the valency is also the same. Hence, the properties are same. Now coming to the next, that is electronic configuration of the elements. To start with, the number of shells. Group. As we move down the group, the number of shells increases. Example, elements of group 1 in the periodic table. So you can see that hydrogen with atomic number 1 has just one shell, that is K, and it has one electron in there. Lithium with atomic number 3 has two shells, that is K shell with two electrons and L shell with one electron. Then coming to the next, that is sodium with atomic number 11 having three shells, K shell with two electrons, L shell with 8 electrons and M shell with 1 electron. Then potassium with lithium with atomic number 3, you can see it has two shells, K and L, with 2 and 1 electron respectively. Then we have beryllium with 4 atomic number with 2 and 2 electrons in the K and the L shell. Then we have boron with atomic number 5 with 2 electrons in the K shell and 3 electrons in the L shell. Then we have carbon with atomic number 6 with 2 electrons in the K shell and 4 electrons in the L shell. Then we have nitrogen with atomic number 7 with 2 electrons in the K shell and 5 in the L shell. Then we have oxygen with atomic number 8 with 2 electrons in the K shell and 6 electrons in the L shell. Then we have fluorine with atomic number 9 with 2 electrons in the K shell and 7 electrons in the L shell. Then we have neon with atomic number 10 with 2 electrons in the K shell and 8 electrons in the L shell. Now, coming to the next, that is valency electrons. The electrons present in the outermost shell of an atom are called as valency electrons. In the group, as we move down the group, the number of valency electrons remains the same. Therefore, the elements in the same period have similar chemical properties. I can ask you this even as a assertion and a reasoning type of a question. Remember, I can say assertion, the elements in the same period have similar chemical properties. Reason, the number of valency electrons they possess is the same. So both assertion and reason are the correct statements, and the reason is the correct explanation of the assertion. So such questions can be asked. Now, as we move across the period, the number of valency electrons increases. Valency. The combining capacity of an element is called as valency. As we move down the group, the valency remains the same as the number of valence electrons are the same. Now coming to the next, that is period. As we move across the period, the valency first increases and then decreases and finally becomes zero in case of inert gases. Example, elements of the third period. Now, element sodium with atomic number 11 with electronic configuration of 281 and valency being +1. Then we have magnesium with atomic number 12 with electronic configuration of 2, 8 and 2 and valency being +2. Then we have aluminium with atomic number 13 with electronic configuration of 2, 8, 3 and the valency being +3. Then we have silicon with atomic number 14 with electronic configuration of 2, 8, 4 and valency being +4. Then we have phosphorus with atomic number 15, electronic configuration being 285 and valency being -3. Then we have sulfur with atomic number 16, electronic configuration being 286 and valency being -2. Then we have chlorine with atomic number 17 and electronic configuration being 287 and valency being -1. Then we have argon with atomic number 18, electronic configuration 288 and the valency being 0. Now, coming to the next, that is according to the modern periodic law, the properties of an element depends upon first atomic size, second metallic character, third non-metallic character, fourth ionization energy, fifth electron affinity, sixth electronegativity. Now let's understand something about atomic size. It is taken as the distance between the nucleus and the outermost shell of an atom. As we move down the group, the atomic size increases as the number of shells increases. As we move across the period, atomic size decreases as the nuclear charge increases, but the number of shells remains the same. Coming to the next, that is metallic character. It is the tendency to lose electrons easily. As we move down the group, metallic character increases. And as we move across the period, metallic character decreases. Coming to the next, that is non-metallic character. It is the tendency to gain electrons. As we move down the group, non-metallic character decreases. As we move across the period, the non-metallic character increases. Coming to the next, it is ionization energy. It is the energy required to remove an electron from the outermost shell of an atom in its isolated gaseous state. Please remember, it's a very, very important point. As we move down the group, the ionization energy decreases. As we move across the period, ionization energy increases. Now, remember, inert gases have maximum ionization energy. Metals have low ionization energy. Coming to the next, it is electron affinity. It is the energy released on adding an electron to the outermost shell of an atom in its isolated gaseous state. As we move down the group, electron affinity decreases. As we move across the period, electron affinity increases. Inert gases have zero electron affinity. Non-metals have high electron affinity. Halogens have maximum electron affinity in their respective periods. Coming to the next point, that is electronegativity. It is the tendency on the part of an atom to attract the shared pair of electrons towards its side. As we move down the group, electronegativity decreases. And as we move across the period, electronegativity increases. The acidic character of oxides increases as we move across a period. Example, Na2O, which is basic, MgO, which is basic, Al2O3, that is amphoteric, SiO2, that is acidic, P2O5, that is acidic, SO2, that is acidic, Cl2O7, that is acidic. The basic character of oxides increases as we move down the group. The common feature seen at the end of every period is the presence of an inert gas with a complete octet or stable configuration. The striking features of alkali metals are: first, highly electropositive in nature; second, good reducing agents; third, valency is +1; fourth, they have low ionization potential; fifth, they form ionic chlorides; sixth, good conductors of electricity; seventh, they have largest atomic size in their period; eighth, they react vigorously with dilute acids and cold water to liberate hydrogen. The reactivity decreases on moving down the group. Now, the striking features of halogens are: first, highly electronegative in nature; second, good oxidizing agents; third, valency is -1; fourth, they have high electron affinity; fifth, they undergo ionic bond formation with metals; sixth, poor conductors of electricity; seventh, they have smallest size in their period; eighth, they do not react with dilute acids. Coming to the next, that is variation of periodic properties across the group and the period. Periodic property, that is valency. Across the group it remains the same. Across the period it first increases and then decreases. Atomic size increases across the group whereas decreases down the period. Ionization energy decreases in a group, increases in a period. Electron affinity decreases in a group, increases in a period. Electronegativity decreases in a group, increases in the period. Metallic character increases in a group, decreases in a period. Non-metallic character decreases in a group, increases in the period. Acidic character of the oxides decreases in a group, increases in the period. Basic character of oxides increases in a group, decreases in a period. Number of shells increases in the group, remains the same in a period, and number of valency electrons remains same and increases, remains same in the group and increases in the period. So friends, we have completed reading the first chapter. Okay, so now I shall request you to hang on so that we can do the reading of the other chapters followed by solving the papers in the live streaming. Okay, we will do as much as possible. So stay connected, hit the bell icon. If you've really liked our efforts, put up a hit button. Like the button also. And please ensure that you tell your friends so that all of us can be studying together. Thank you so much.